Hello everyone. So today we are going to see the Leetcode POD and the problem is most profit assigning work. So we are going with the problem statement first and the test cases. Then we will get the intuition and solve the problem. So here it is given you have n jobs and m workers. You are given three arrays: difficulty, profit, and worker. Where difficulty of I and profit of I are the difficulty and profit related to that ith job, and worker J is able to do the difficulty label of at least worker J given, and every worker can be assigned at most one job, but a job can be used multiple number of times. So here we will go with the test cases and the constraints as well. So here the first example is given: difficulty, profit, and workers. So here it is like firstly we will check whether there are difficulty label which is less than or equal to the worker having the difficulty label. So 4 it is given, and here when we will search in the difficulty, we see that yeah, there is 4 and 4 present, so we can assign this difficulty label and profit associated with it. So profit associated with is 20, and we can assign this. And when we will go for 5, then we will see that okay, for there are no difficulty with 5, but yeah, less than 5 is 4, which is the maximum difficulty it can assign. So the profit associated with difficulty 4 is 20, and we will give that. And here similarly for 6 and 7 is also it is 6 and 6 only, because 7 is not present and 6 is the maximum number which is lesser than 7. So the maximum profit for all those workers are 20, 20, 30, and 30. So all those sum up to 100. And when we will go for the second example, we see that here worker given are 40, 25, 25. So when we will search for 40 in the difficulty, there is no 40 present here, or less than 40 present here. So we cannot assign anything to 40 because difficulty level is higher than 40, and there is no lesser than 25 as well, and for 25 also. So here we can see like if the test cases are given which is not clarifying the thing that we have to choose the maximum profit. Like here it is given 22 is having the profit of 10 and 4 is having the profit of 20, but it is not necessary that if difficulty is less, then will also be less. There can be test cases where two like difficulty level of 2 can have more profit. Like let's suppose profit of 2 is uh, 40 and profit of 4 is 20. Then when we are choosing the for 4, then the difficulty maximum difficulty can be chosen for 4 is 4, but the profit is maximum up to 4 is 40 now, because here we are if we are taking here 40 for difficulty level of 2, then we can choose 40 because we have to maximize the profit. So whenever we are getting some less profit, then we will acquire uh, the previous profit if it is greater than the current one. So this can be solved by this intuition here. The main intuition behind the problem solving is we have to keep the difficulty and profit in a same array, and we will sort this based on the difficulty. And after that, the thing is the profit and difficulty will get sorted inside the array, and after that we will check whether the current profit is less than or less than previous or not. If it is less than the previous profit, then we will update it to the previous one. So let's code it out and see the solution. So Yeah, we have to take care of the work and the difficulty and profit associated with it. So we are going to take a two-dimensional array work, and inside that we are going to put uh, the profit and difficulty associated with it. N is the length of the profit and difficulties array are uh, of same size. Now we are going to put all those difficulty and profit value inside the. Now we will sort it out, and then we have to go inside the work array and update it, and then we have to search for the worker in the sorted work uh, array. So here we will search for the workers I less than worker dot length I plus plus sum plus, and here we will as this is a sorted array, so as the work is sorted based on the zeroth index, we can apply binary search to get the maximum value which is less than or equal to the target value, means the worker difficulty level. So here we will search binary search sum is equal to 0, and yeah, now we have to return the sum. So here we have to apply the binary search function. The lower value should be 0 and the higher value should be work dot length minus 1. This is the mid value, and if work of mid of 0 is less than or equal to the target difficulty, then we will keep the answer as the work of made of 1, and we will try to maximize it. That's why we will increase the point lower pointer to mid plus 1, so mid plus 1. Otherwise we will decrease the, if it is not uh, if the mid of the work sorry, if the mid value of the work of 0 is greater than the target difficulty, then we are going to decrement the low higher value to mid minus 1, and we will return answer. So what should be the initial value of answer? Answer should be initially assigned as 0, because if we are not getting any value which is less than or equal to the work of mid value, then we are going to put it as 0 only. That's why we are using here answer as 0. And yeah, now binary search will give us, let's run it. Okay, here I have used L and H only, so rename it. Sorry, it should be 1. Hmm. Yeah, because we are looking for the profit. If the current profit is less than the previous one, then we are going to update it with the maximum one. Yeah, now submit it. Yeah. So here we can see it is beating 49%. Okay, let's go with the time complexity and space complexity associated with this solution. So time complexity will be big O of n log n, because we are using arrays dot sort, which takes n log n time complexity, and for binary search also we are taking n log n. That's why the time complexity is all over big O of n log n, while the space complexity is big O of 2n, which extends to big O of n only, because we are using a two-dimensional array where the dimensions are n into 2 means 2n, and which extends up to n, so big O of n. So this was the time complexity and space complexity associated with this solution. Let's go with another optimal approach. Okay, so to think about the optimal approach, we should once go through the constraints deeply and understand how these constraints are helping us out to decide the array which is helpful without having the sorting algorithm. So if we are going to keep the difficulties and the maximum profit associated with this difficulty, then definitely we can help what is the maximum profit for the current difficulty of the worker can be, and that's how we are going to optimize this solution. So firstly we are going to take the length of profit, and to get this approach we are going to keep one array of dp, and here we are keeping the maximum length of dp as 10 to the power 5 plus 1, and we are going to keep the maximum difficulty and the profit whatever the maximum value is assigned to the current difficulty level. So now we are going to uh, see if the previous difficulty is having more profit, then if we are going to acquire those profit to the current difficulty. Otherwise it will be the previous, it will be the same whatever the value it is having. So it will start from 1 and it will go till dp dot length. We are going to sum up all those required difficulty in present in the worker, and from we will fetch all the values from the dp array. We will traverse in the worker array and sum up all those values associated in the dp array. Let's run it. Yeah, all these values are getting accepted. So let's analyze how these are working. Like, yeah, so for if we are not using event sorting, then how this is working, let's dry run it and understand how it is working. So here we have taken a dp array of length 10 to the power 5 plus 1, and let's suppose when we are traversing in the difficulty uh, array, then dp of difficulty of I is let's suppose here 868, then 68 dp of 68 will be the maximum of profit associated with this or the previous value which was initially assigned. So initially it was 0 and now it is 67, so 67 will be assigned to 68 uh, in the dp array. And then when we are going with 35, then it is previously was 0 and now it is 17, so it is 17, and so maximum value will be 17. Then after that 52 is 1, and for 52 it is 1 and 0, so 1 will be assigned in 52 in the dp array. And then similarly for these two also, because there is no repeated value, then all these values will be assigned to the in the dp array. And after that we have all these values assigned, and after that now we are having a sorted array only, because when we are taking index wise in the dp, then we are having all these values in sorted only. We don't need to do uh, sorting, and then we are just checking if the previous value is greater than the current profit, then we are going to update it. So this is how we are updating without sorting. And after that we are traversing in the worker, and then uh, we are summing up whatever the values are there in the dp array. That's how this solution works without sorting, because we are just using an array, and that is helpful. And the time complexity will be here big O of n, while the space complexity is also reduced to big O of n only, because we are taking only 1D array, and the length is 10 to the power 5 plus 1 means yeah, that is also within the constraints, and that's how this solution should work perfectly and accept and should be accepted here. So let's submit it. Yeah, so this is beating 97%, and yeah, runtime is also given in 9 milliseconds. So this is uh, very optimal when we compare to the previous solution, because the previous solution was in time complexity of big of n log n, while that space complexity we were taking there was big of 2n, means more than this only, and we have to sort that out as well. So this solution is a bit optimal regarding to the previous one. So this was the solution. Thank you.